here's the big difference between the first solution and the second solution. What did we do with beta on the first solution? When you were up here, you lowered beta. And as you lowered beta, this came down. Now what happens? When you lower beta, it comes up. And on the third one, when you lower beta, it comes down again. You see how this alternates? Your search strategy has to be different for every other mode. Because in before, what we're saying is, I'm going to keep lowering beta. Once I go past it, go back up and zoom in. But now it's the opposite. If I'm below it, I got to go up. That make sense? I have to flip how I was looking at things. Okay, this also now requires one more loop. I have one solution. I want to get 5 of them. So I'm going to, let's say, I have to make a loop outside of all this that goes from 1 to 5. Right? I'm going to find one solution, plot it, find another solution, plot it, find another, plot it, get 5 of these. So now we have to add one more loop in here. So right now we got 2 for loops, one embedded inside the other with 2 if statements embedded inside that. Okay? That's our logic count. Okay, so we're still going to start here at 99. We want to go find this solution. We'll just pick d beta to be 1. But now, what we want to do, and I'll tell you why I'm going to do this. So first of all, let's uncomment all that out for a moment. And text, uncomment. And we're going to get rid of this again because we don't need to see this anymore. Okay. And here, let's go back to what we had. Oops. Text, uncomment. Okay, so here's what we're going to do. We're going to make another loop for jj equals 1 to 5. Okay. Now, why did I put this all the way here? So what I want to do is one wrapper around this thing. It's going to go through 5 times. It's going to start with 99. Now, notice what we have so far in the loop. We pick a d beta 1. And once we have d beta 1, we're going to come through and look for solutions here that if it's above 0, right? If it's above 0, start to lower it. If it's below 0, raise it. We want the exact opposite of that to happen for the second mode. How do you do that? Pretty easy, actually. Here's what you can do. You can come here and do the following. Times -1. Let's do this. Raised to the jj plus 1. So notice, when jj is 1, 1 plus 1 is 2. -1 squared is 1. So the first time through the loop, this is just 1. Second time through the loop, this is 2 plus 1 is 3. -1 to the third power is -1. So it flips the sign of that thing. So it flips how we look at it. It just does it the opposite. So now I can come down, look for it, and then when I come up, it looks for it. That's it. I know. Super awesome, right? I told you. Heck, I got a lot of time to kill. Should I tell you about my weekend? No? All right. No, let's see if we pull this off. So this is it. That's it. So it's going to do this. So for every mode, so the first time through the loop, it's going to start at 99, go find this thing, just like we did before. It's going to give us a value. Okay? Now, before we cut out of here, this loop, after it finds this value, let's say, okay, beta. Let's print it to the screen, what the beta value was. Now, that beta value was 97 point blah, 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 blah. Now, I know the next mode is below that. And I don't want to start on 97 when I look for the next mode, because 97 is the solution. I want the one that's further down from that. Okay? So what I have to do is print the beta value, and then I can say beta is equal to beta, like, -1. So if I find the solution, 97 point whatever, I'm just going to say, okay, I'm going to start looking next time, because right here is where my end statement comes. Now it's going to go jj is 2. Start looking again. So what I want to say is, it was at 97.5. I'm going to start at 96 point something, and then start going down from there. No, because now, because I've switched the signs, it will start looking the other way. It actually only there. You feel more comfortable? All right. Fine. I hear you. You actually have to be careful with nonlinear problems. You pick this number, you'd like to automate this, but ultimately at the end of the day, you have to pick, the smarter you are about picking this information in there, which if you have an idea of where these betas sit, you'd pick better here. So we'll pick betas too. Start looking for the next thing. And by the way, when we plot, we'll do a hold on. So we plot it, hold on. Next time it comes through, plots it again. We just plot and overlay them on each other. There we go. Check it out. That's right. I know. Usually, you know, every year I get people standing and screaming at that point. But I guess maybe you guys are just more subdued. Here are the 5 solutions to this thing. They all launch from here. They land to there. This is the first one. Second one is right here. Third one. Fourth one. Just add more wiggles. By the way, they're just all sines and cosines. Okay? Because I picked a very simple problem. Okay? So what we have now is in a full code. If you look at the code in the book, I have a few extra bells and whistles on this thing. In particular, 2 other things that were done for this. One, notice that when I do these solutions, every one of them has different area under it. What I want is solutions that are normalized. In other words, the area under each one of those eigenfunctions is 1. So you'd still have to do a normalization. 2, which is even more important because it's sort of shallow and goes right along with me, is you can put them in different colors. I know. This is really what counts in this class. Okay, so you can do that, and then so look at the code in the notes. It's all there, and you can download it and play around with it. But there's your solution technique.